An anchor is a device, normally made of metal, used to connect a boat to the bed of a body of water to prevent the boat from drifting due to wind or current. All anchors depend on their ability to bury themselves in the seabed to achieve their holding power. To do this, they need a certain amount of weight, sufficient to start the burying process, and a near horizontal pull. Boats are required to carry anchoring and mooring equipment suitable for the size of vessel and waters in which it operates. Boats of less than 12 meters in length and certified to operate only in protected waters, that is, within 3 miles from a safe refuge, are permitted to carry just one anchor. Most of the time, the seafarer cannot see the anchor on the seabed. So the anchor had to be designed to function the same way all, or at least most, of the time. One end of the anchor is made much heavier than the other to ensure that end of the falling anchor the first to make contact with the seabed. This part is called the crown. The seabed in some areas can be rocky, so the crown has to be able to withstand falling onto a rocky surface. The crown is shaped and sized to make the anchor fall over once it has landed on the seabed. The crown supports the flukes. The flukes are the part of the anchor that designed and positioned to dig into the seabed. To assist the flukes digging into the seabed, they are positioned on the widest part of the crown. This widest part is called the tripping palm. The shape of the tripping ring ensures the flukes point initially slightly down into the seabed. The crown is also manufactured with a pivot at the center. A relatively long and very strong piece of steel has one end attached to the pivot in the crown. This long piece of steel is called the shank. This pivot allows the shank to be several degrees out of alignment with the flukes. The shank can lie flat on the seabed while the flukes are dug into the seabed. The opposite end of the shank is attached to the anchor cable or chain. On the left here, we see the anchor just after it hits the seabed. Having embedded itself, resistance to movement through the seabed is related to the amount of material that would be removed by the anchor if it pulled out. It follows that in principle an anchor with the largest effective fluke area has the highest holding power, subject of course to it being of sufficient strength. The essential features of an efficient anchor include having enough weight for the initial penetration of the seabed. The anchor must bury itself deeply when subjected to a horizontal pull. Once buried, the anchor must have the greatest possible resistance to movement in the direction of pull. A good anchor must remain rotationally stable even when pulled through the seabed. The anchor must be able to break out of the ground easily when pulled upwards. The holding power of any anchor varies with its size and with the seabed. The seabed is far from uniform. Even within a relatively small area, an anchor performance is affected not only by the nature of the bottom, whether it is mud, rocks, sand, silt or shells etc., but also man-made inclusions like scrap metal. Compared with sand, soft mud reduces holding power by about a third, whereas firm clay can increase it by as much as 2/3. The vessel is attached to the anchor by the rode, which is made of rope, chain, cable or any combination of the three. The ration of the length of rode to the depth of water is called the scope. A grapnel anchor is light and generally used for small boats such as pirogues, kayaks, dinghies and canoes. It's also popular with fishermen. A grapnel anchor's holding power comes from hooking onto another object, such as a rock. The Danforth has wide, flat and sharp flukes. This type of anchor readily digs itself into mud and sand when it is heavy enough. It has a stock located at the head or crown which gives initial stability and alignment to help it dig in. The Danforth anchor's crown design is such that it offers little resistance both during the burying operation and also when it is being broken out again. It has the advantage of folding flat for deck stowage. The stockless Plough anchor is remarkably effective and, in its heavier sizes, penetrates kelp and seaweed, shell and overlying gravel better than most lightweight anchors. The Plough anchor is extremely efficient in mud and sand, and once buried will remain so even though the direction of pull changes with wind or tide, thanks to the angled hinge on the shank. When an anchor is more than 30 kilograms, an efficient mechanical means shall be provided for handling the anchor.